another method of solving system of linear equations is called elimination method. Now, some books do also call this addition method. So addition or elimination method, they're both the same. Now that means, as the word indicates, in this case we have to eliminate a variable. Now either we're eliminating the x or the y. This really depends on the student. Which do you think is easier to eliminate? And when we eliminate, when I say eliminate, what that means is we have to have opposites. So in order to get rid of a variable, we either have to have a plus 3x and a minus 3x. So neither one of those two equations are set up that we can just eliminate. What that means for us is that we have to change the equations first. So I'm going to eliminate the y first. And let me tell you why I picked y and not x. And you got to look out for those things, because the y's already have opposite signs. That's how you eliminate a term with opposite signs. So if I pick the y, I don't have to worry about multiplying anything by a negative number. All I need to worry about now is what number do I need to multiply both of these equations by to get opposite number. And this is similar to finding the least common denominator. What is the least common denominator of 3 and 5? That would be 15. For the first equation, I already have a 3, so to get to a 15, I need to multiply every single term in the first equation by 5. So I usually put a little arrow there and write times 5, but sometimes I write it like this as well, so we don't forget the number on the right-hand side. Multiply everything by 5 is 30x minus 15y equals negative 15. Okay, there's my 15y. Now the second equation, I already have a 5y and I need to get to a 15y. So in this case, I need to multiply every single term by 3. Times 3, times 3, times 3. That gives me 4 times 3 is 12x plus 15y equals negative 27. Okay, we have opposite terms now. We can eliminate them. How do we eliminate? We add them. And that's why it's sometimes called addition method, because the next step is to add. 30x plus 12x is 42x. The 15y's, that was our whole reason why we did that, cancel out. And on the other side, we have negative 15 plus a negative 27, and that is a negative 42. Ooh, this works out fairly nice. Divide by 42, both sides to get x by itself. Negative 42 divided by 42, the answer is x equals negative 1. This is our first value. Don't stop here. You also need to find the y value, and to find the y value, you want to substitute it into one of the two original purple, in this case, equations. So again, try to be smart about it. Look for signs. Do I have negative, positive, smaller numbers? In this case, it doesn't really matter. I'm going to substitute the x equals negative 1 into the second equation. And that way, I'm going to find y. 4 times x, x is negative 1, plus 5y equals negative 9. 4 times negative 1 is negative 4 plus 5y equals negative 9. Add 4 to both sides. 5y is equal negative 9 plus 4 is a negative 5. Oh, look at that. Divide by 5. Oh, have no more room. Y is also equal to a negative 1. Negative 5 divided by 5. Therefore, our ordered pair is negative 1 comma negative 1. We get one solution, which is our first case here, where the lines, if we were to graph them, intersect. Here's another systems of linear equations we want to solve by elimination method. Elimination method, you have to eliminate one of the variables. Let's take a look here. We have a negative x and a 3x. So I'm deciding, they have opposite signs. I'm deciding to eliminate the x. Now, I already have a positive 3x in the bottom, which means the top equation has to be multiplied by 3. Each single term multiplied by 3. I don't have to worry about a negative sign because I already have that here. 3 times negative x, negative 3x, plus 3 times 3 is 9y equals 18, 6 times 3. The second equation, I'm just going to bring over. I do not need to make any changes. 3x minus 9y equals 9. Now comes the eliminating adding part. So what happens here? Negative 3x and a positive 3x cancel each other out. Oh, look at that. 9 and negative 9y, they cancel each other out. The left-hand side, I'm left with 0. And on the right-hand side, I get 18 plus 9. 18 plus 9 is 27. So my variables all canceled out. I have 0 equals 27. Is that really true? No, that's not true. That's a contradiction. When this is the case, when you have your variables canceled out and that is equal to some kind of number, we get our parallel case. Here the lines, if we were to graph it, are parallel and we have no solution. This is our second case with no solution. Let's solve this system of linear equations by elimination method. Yes, we do have fractions, which I call fraction action. We need to clear the denominator here. That makes it way easier for us. So in other words, we're looking at the first equation and we have to find the least common denominator, and the least common denominator of 4 and 2 is indeed 4. We're going to multiply each term by 4. I'm going to write 4 over 1 so you know how to reduce this the proper way. Why do we do this? To clear the denominator. 4 goes into 4 one times, which leaves me with, let me write it down here, 3x. Now I'm going to the 5 halves times 4 over 1. 2 goes into 2 ones and into 4 twice. I've cleared the denominator. 5, don't forget this 5 here. 5 times 2 is 10y. Now that is equal to, there's nothing I can reduce, so I just multiply 11 times 4, which is 44. Now I'm looking at the second equation, and I do the same thing with finding the least common denominator of 16 and 4, and in this case that would be 16. So I multiply by 16 over 1, 16 over 1, and by 16. Again, to clear the denominator, 16 goes into 16 once. 1 times x is x, minus 4 goes into 4 once and into 16 4 times. Don't forget this 3. Minus 3 times 4 is 12y. And Here there's nothing to reduce, so we're just multiplying negative 16. This is our new system of equations. If we solve this by addition method, we want to now see, okay, which variable is it that I can eliminate? Which one is easier to eliminate? And if you look at the y term, you see you have a 12 and a 10. They have nothing in common, so I would have to change both of these equations. But if you look at the x term, we have a 1x and a 3x, so that is perfect. We're taking the second equation. We want to eliminate the x, and we do so by multiplying each single term by, I already have a positive 3, so in this case I would need a negative 3. Negative 3. So negative 3 times x is negative 3x. Negative 12 times negative 3 is positive 36y. And negative 16 times negative 3 is a positive 48. So I changed the second equation and I multiplied everything by negative 3. The top equation, I just copy over. There's nothing I need to change. Plus 10y equals 44. So I'm going to add both of these equations. I can eliminate the x's. 10y plus 36y is 46y, and 44 plus 48 is 92. I divide this by 46. 92 divided by 46. You either use your calculator or you know that 92 divided by 46 is 2. Y is equal to 2. Now you need to find your x value. I'm going to plug in the the y value into my green. I need to find x, not y. I'm plugging in the y value into the green equation. Replace y with 2, and that way I can find x. X minus 12 times 2 equals negative 16. I have no more room, but I can. X minus 24 equals negative 16. Now to get x by itself, I'm going to add 24 plus 24. X equals negative 16 plus 24 is a positive 8. Beautiful. Here you go. Our ordered pair, in this case, they do intersect at one point, is 8, 2. This was our fraction system of equations.